Welcome, math enthusiasts. In this video, I'm going to teach you what a derivative means, and in calculus, and how to compute it using the limiting process, something called the limiting process. This is the beginning of learning what a derivative is and how to compute it. So let's get started. So let's talk about a linear function. If you remember in algebra, we talk about linear equations, something that looks like this, like a linear function. It's just a straight line on a plane. Notice, if you remember, the derivative, the slope of a line is always the same. So m is fixed for a linear function. Linear function. So the derivative arise from different problems in mathematics. Some of those problems are the area problem. Another problem would be to find the slope of the tangent line of a curve. For example, let me give you what that means. Notice, linear function is always the same. So when you find the slope, it's always going to be the same for every point in that line. But what happens if you have like a curve like this, and you have the plane here? Notice, if you want to compute the slope of the curve at a point, the slope of a curve of a point is called the tangent. Is the slope of the tangent line at that point. For example, the point here, the tangent line would be somewhere like that. So the slope of this point is called the slope of the curve, and that slope, we call it m. It's not gonna be the same at every point in this curve. It's always gonna be different at every point. So we needed to, so mathematicians needed to learn how to do this type of problems. So they come up with calculus, and calculus gives us the answer to this question. So the slope of the tangent line, of a tangent line to the point at a curve or a line, is called the derivative. The derivative is a function of x, provided that the limit exists. I'm going to show you what that means. So let's say if this is m here, then the derivative at that point is gonna be m, the slope. So the derivative when you at a point is a number, because when you plug in your x, it's gonna give you a number. For example, let's say x here is -50, and let's say that the slope, I'm not gonna give you an exact derivative function for this particular function, but let's say it is x plus 3. So then once you have, let's say this, and then the derivative is written like this: f prime of x. F prime is just a different way of saying derivative. We can also say something called like this: dy dx, or d of derivative of f of x. There are different ways of writing derivative, but most commonly is like this. So let's say that we found that remember, the derivative is a function of x. So let's say x is -50. So to find the derivative, so in other words, to find the slope here, all we have to do is plug in -50 into our function. Remember, this is just an example, so it's not going to be the exact derivative function. So let's plug it in: -50 plus 3. That gives you -50 plus 3. That will be your -47. So that is your derivative. That is your slope of the tangent line at that point. In other words, you only care we only care about finding the slopes here right now when we're talking about derivatives. The slope of what? The slope of the tangent line at that point. Anyways, so remember the nonlinear functions they have different slopes at every point. It could be the same. It's not always going to be the same at every point. Not always. But if you have a straight line, then it is the same. So a slope is fixed. That would be m equals 5, for example. Or something like that. So derivative, a function could be differentiable. So when a function is differential, we call it that means that derivative exists at that interval. So a function could be differentiable at every single point, at some points in the interval, or nowhere. We'll learn about that. We'll learn about those things later. But let's define the definition of the derivative, or what it means. Remember, the derivative is the slope of the tangent line of a graph. The slope of the tangent line of a graph. And how mathematicians came out with this definition is because let's say we have a circle and we have 2 points. So 2 points here. The secant line looks something like this. But let's say I want to find the slope of the tangent line at here. Well, what I can do, because we've been talking about limits, right? We can say that we can approximate this derivative or this slope by doing secant lines. For example, the secant lines are approximating the tangent line if your delta x, something called delta x. In other words, your range of x's. In other words, you're approaching the tangent line, the slope of the tangent line by making these secant lines smaller in the circle. And a similar process can be done with any function. Not any function, but functions that have a derivative. So this is how they came out with it. So the definition of the derivative, remember, a definition is a definition. So we're gonna say a function, a derivative is something like this. It's a function, f of x is f prime of x in terms of x of f x plus delta x minus f of x over delta x. And notice this function is very similar to our algebra definition of slope. Remember when we did y2 minus y1 all over x2 minus x1. It's very similar. Actually, delta x is something like this, and y2 we're doing the same thing, almost the same thing. In other words, we're upgrading our knowledge of algebra. So once we know this definition, this is the definition of the function of the derivative. And this definition prevails whenever the limit as delta x approaches 0 of f of x plus delta x minus f of x all over 2x approaches. So when this limit exists, we know that the derivative exists at that point, at that x. So once with this one checks, this one checks. That means we can find the derivative. So now let's go to our final topic in this lecture, which is gonna be how to find the derivative the formula of the derivative of the slope of a curve. So our function is going to be, so let f of x equals x cubed minus 12x. So that's our original function. Notice this is a nonlinear function, so we're not gonna have a fixed number for the slope of this at every point of this curve. Slope is not going to be the same, so we need to find a function for it, and we can find it using calculus. The way we do it is using the limiting process. And how do we find that function f prime of x? We're gonna take a limit as delta x approaches 0 of, remember, so we're gonna do x plus delta x cubed minus 12 delta x plus delta x plus delta x minus the function x cubed minus 12x all over delta x. So basically this is a mechanical process. We find that the function of the derivative by doing this limiting process. We need to find the limit of this expression. This here I already computed for you, so that's gonna be limit as delta x approaches 0 over, it's gonna be x cubed plus 3x squared delta x, 3x squared delta x plus 3x delta x cubed, and then here minus 12x plus, or minus, because minus here, minus plus is gonna be minus, so minus 12 delta x, and then here distributing, that will be minus x cubed plus 12x all over delta x. Notice now we can combine like terms. This one goes with this one, this one goes with this one, and all we're left is this one. Limit as delta x approaches 0 all over delta x. So 3x squared delta x plus 3x delta x cubed minus 12 delta x all over delta x. So that's it. Let's see. The cancel. Okay, yes. Okay, next step, we can divide delta x and delta x here. So this cancels with this cancels, this one with this one, we're gonna left with something, and this one cancels. So all we're left is limit as delta x approaches 0 of, oh no, we're gonna simplify. Okay, so delta x and delta x cancel, so we're gonna left 3x squared plus 3x delta x squared, because they have delta x, we have delta, so we cancel, minus 12 delta x and delta x cancel. Okay, so now final step is to take the limit of this expression. Remember, delta x approaches 0, so that means that if we plug in 0 here, this term cancels out, and all we're left is 3x squared minus 12. And that's the limit, that's the derivative, so f prime of x is going to be 3x squared minus 12. That's our answer. So notice this is called the limiting process. We find that derivative function by doing this sort of process, limiting process. All right, so that's all I wanted to teach you on this video. So thank you very much, and don't forget to subscribe to my YouTube video. Thank you very much.